I'll just recap whatever we discussed. Morning we discussed, these are the few concepts which we discussed. Problems based on reminders, we discussed how to find out positive reminder, how to find out negative reminder, how to find out negative reminder, how to find out positive reminder, how to find out negative reminder, how to find out problems based on numerator power x when divided by denominator, how to use the concept of plus or minus 1. Just let me revisit all the concepts. First problems where it is numerator divided by denominator. First problem, second problem, I'm just revisiting the concepts. First, second, third, fourth, students who miss the morning class, these are all the problems which we discussed it. 1, 2, 3, 4, 5, 6, 7. Seventh question is on factorial. 8th question, 9th question, 10th one, 11th one. I hope this sound problem is not there right now. Rahul, I hope the audio issue is resolved.
Discussed it. 1, 2, 3.
13th problem, 14th one, 15th, 16th morning problems, I am just revisiting it. 17th, 18th, power to the power problems, how to check whether if I take plus 1 how to solve it, if I take minus 1 how to solve it. 11th one, 12th, 23rd, 25th, 26th, 27th, 28th. Right. Now let us solve 29th and 30th based on Euler's theorem. Please write down few concepts. Euler's theorem. Now in negative remainder problems there are few drawbacks. In negative remainder problems there are few drawbacks. For example, if I were to solve remainder 2 power 100 divided by 153, checking which power of 2 when divided by 153, plus 1 or minus 1 will be difficult. Just give me, right, plus 1 or minus 1, it will be difficult. So how to solve this? By using Euler's theorem. Euler's theorem. Now see here, Euler's theorem. How to find out using Euler's theorem? Euler's theorem is used to find remainder problems. Remainder problems when the denominator is a composite number. When the denominator is a composite number. Euler's theorem is used to find the remainder problems when the denominator is a composite number. The theorem suggests remainder Reminder: a power phi of x by x equivalent to 1. A and x should be co-prime to each other. First write down this, then I'll explain. A and x are co-prime to each other. HCF of a comma xc should be 1. Then only the numbers are said to be co-prime, and x is a composite number. X is a composite number. Euler's theorem is used to find out the reminders of problems where the denominator is a composite number. Theorem suggests a power phi of x by x equivalent to 1. A power phi of x by x equivalent to 1. A comma x are co-prime to each other. Two numbers are said to be co-prime if their HCF is 1, and the denominator should be co-prime to each other. And the denominator should be co-prime to each other. Now, what is phi of x? Which I'll explain it. What is phi of x? Please write down in the same order. Phi of x. I'll write down the theorem here. Reminder 1. A power phi of x divided by x should be 1. X should be a composite number. What is phi of x? Phi of x is a tangent function of x. Tangent function of x. What do you mean by a tangent function of x? Tangent function means it will tell the number of natural numbers. Number of natural numbers less than or equivalent to x, less than or equivalent to x, less than or equivalent to x, and co-prime to x. We'll see what is tangent function, how to derive the numbers which are less than or equivalent to a number and co-prime to x. Remember, Euler's theorem is used only when the denominator is a composite number, first point, and the numerator and denominator should be co-prime to each other. We can easily determine how we will get the remainder 1 by using this tangent function. But before using it, we need to understand in detail what is this tangent function by taking few examples. Write down one example. This is the tangent function. What is a tangent function? We will do it. First question. How many natural numbers less than or equivalent to 12 are co-prime to 12? Please write down the first question. How many natural numbers less than or equivalent to 12 are co-prime to 12? How many natural numbers less than or equivalent to 12 are co-prime to 12? Now see here. Method 1. What are all the natural numbers less than or equivalent to 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all the numbers. These are all the numbers which are less than or equivalent to 12. Natural numbers are co-prime to 12. Co-prime means HCF should be 1. HCF of x comma 12 equivalent to 1. How many values are there? 1 is a co-prime. HCF of 1 comma 12 is 1. Yes. 2 comma 12 no. 3 comma 12 HCF is not 1. 4 comma 12 no. 6 comma 12 no. 8 comma 12 no. 9 comma 12 no. 10 comma 12 no. 11 comma 12. Now if you observe, HCF of 1 comma 12 is 1. HCF of 11 comma 12 is 1. HCF of 5 comma 12 is 1. And HCF of 7 comma 12 is 1. HCF of 7 comma 12 is 1. 7 comma 12 is 1. Totally how many numbers we got? Totally 4 numbers we got. This process is nothing but a counting process. Instead of 12, if it is 100, 120, 100, 120 like that, then calculation will become difficult. Am I right? How many natural numbers less than or equivalent to 12 are co-prime to 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 is co-prime to 12, 11 is co-prime to 12. 5 is co-prime to 12, 7 is co-prime to 12. 1, 11, 5, 7. Totally 4 numbers are co-prime to 12. Right? So instead of using this, now we will use a quotient function. Quotient function. Now see here. Method 1. Method 1 is a traditional method which is nothing but a counting process. Now we will not use counting process. Method 2. How to use quotient directly. How to use quotient directly. What is that he is asking? HCF of a comma 12 equivalent to 1, a less than or equivalent to 12. How many values a will take? Is this the question, right? How many values a will take? HCF of a comma 12 equivalent to 1, a less than or equivalent to 12. How many values a will take? Now see here. HCF of a comma 12 is nothing but 2 square into 3 power 1 equivalent to 1. Am I right? First write down which number we require 12. Can I say first base is 12? For every two consecutive numbers that comes into your mind, one will be divisible by 2. Am I right? 3 comma 4. 4 is divisible by 2. 8 comma 9. 8 is divisible by 2. 5 comma 6. 6 is divisible by 2. For every two numbers, one number is divisible by 2. But we require HCF as 1. That means out of two numbers, one number is divisible by 2. One number is not divisible by 2. We require a number which is not divisible, because if it is divisible by 2, a is divisible by 2, 12 is divisible by 2. HCF cannot be 1. That means the meaning of this number is numbers less than or equivalent to 12 which are not divisible by 2 and 3. I hope it is clear. Which are not divisible by 2 and 3. Which are not divisible by 2 and 3. Why it is not divisible by 2 and 3? If a is divisible by 2 or 3, then HCF cannot be 1. So out of two numbers, one number is divisible by 2, remaining it is not divisible by 3. If I take for every three numbers, 3, 4, 5, 3 is divisible by 3, 8, 9, 10, 9 is divisible by 3, 12, 13, 14, 12 is divisible by 3. Out of three numbers, one number is divisible by 3. How many are not divisible by 3? 1 minus 1 by 3. So it is 12 into 1 by 2 into 2 by 3. 3 4s are. That is how we got the answer 4. I hope it is clear why I wrote 1 minus something. 1 minus something. Out of every two numbers, one number is divisible by 2. Right? How many are not divisible by 2? 1 minus the numbers which are divisible by 2. 1 minus 1 by 2. Out of three numbers, one number is divisible by 3. How many are not divisible by 3? 1 minus 1 by 3. I hope the idea is clear. Quotient function helps us in determining how many numbers are not divisible by prime bases. How many numbers are not divisible by prime bases. I will do one more question. It will be crystal clear to you after this example. Then I will write down quotient function definition. Now let us take one more question. If I take one more question, how many natural numbers less than or equivalent to 360? Less than or equivalent to 360. First question. Divisible by 2, 3, 5. Divisible by 2, 3 and 5. 360 is nothing but 2 cube, 8 into 9 into 5. 8 9s are 72, 72 5s are 360. Out of 360 numbers, for every two numbers, you take any two consecutive numbers, one number will be divisible by 2. So we only require divisible. For every three consecutive numbers, 4, 5, 6, 8, 9, 10, 12, 13, 14, one number is divisible by 3. We require only divisibility. Out of every 5 consecutive numbers, 1, 2, 3, 4, 5. 5 is divisible by 5. 8, 9, 10, 11, 12. 10 is divisible by 5. One number is divisible by 5. So 6 5s are 30, 30 12s are 360. First one answer is 12. I hope it is clear. Divisible by 2, 3, 5. Out of every 360 numbers, for every two consecutive numbers, one number is divisible by 2. For every three consecutive numbers, one number is divisible by 3. For every 5 consecutive numbers, one number is divisible by 5. Suppose if the question is divisible by 2, 3 but not 5. Divisible by 2, 3 but not 5. Out of every 360 numbers, for every two numbers, one number is divisible by 2. For every three consecutive numbers, one number is divisible by 3. For every 5 consecutive numbers, one number is divisible by 5, but not. That means out of 5, one number it is divisible, 4 are not divisible. 6 5s are 30, 30 12s are 360, 12 4s are 48. 12 4s are 48. I hope it is clear. Again I am repeating. For every two consecutive number, one number. For every three consecutive number, it is one number. For every 5 consecutive number, it is one number which is divisible. So directly 1 by 2 into 1 by 3 into 1 by 5. For every 360 numbers, for every 2, one number it is divisible. For every 3, one number it is divisible. For every 5, one number it is divisible. But the question is but not divisible. So 1 minus 1 by 5 is 4 by 5. I hope the idea is clear. We will create few more questions so that it will be clear. Few more questions. I hope the idea is clear.
Press the bell icon on the YouTube app and never miss another update.
One more question. How many natural numbers? In fact, 2 more we will do so that it will be clear. How many natural numbers less than or equivalent to 360 are, first question, divisible by 2 but not by 3 comma 5? But not by 3 comma 5. What will be the answer? Out of 360 numbers, for every two numbers, one number it is divisible. Not by 3 comma 5. For every 3, one number it is divisible. Not means 1 minus 1 by 3. For every 5 numbers, one number it is divisible. Not means 1 minus 1 by 5. 4 by 5. 6 5s are 30. 30 12s are 360. 12 8s are 96. 12 8s are 96. I hope the idea is clear. Second one. Not divisible by 2, 3, 5. Not divisible by 2, 3, 5. Wherever not is there, do 1 minus the numbers which are divisible. Out of 360 numbers, for every two numbers, 1 it is divisible. So 1 minus 1 by 2. For every 3 numbers, 1 number it is divisible. 1 minus 1 by 3. For every 5 numbers, 1 minus 1 by 5. 4 by 5. 6 5s are 30, 30 12s are 360. 12 8s are 96. Idea clear, right? Right? Divisible by k and not divisible by k. How to solve it? I hope it is clear. Again I am explaining. Euler's theorem is used to find out the remainders when the denominator is a composite number. Euler's theorem uses quotient function to find out which power of numerator when divided by denominator I will get plus 1, and that function is nothing but quotient function. What is the definition of quotient function? It will tell the numbers which are less than or equivalent to given number and co-prime to that given number and co-prime to that given number. Now we will write the quotient function clearly. Now it will be very easy for you to understand. Reminder, a power phi of x by x equivalent to 1. What is x? X is a composite number. X is a composite number. Instead of x, what? Okay. Composite number means if composite number can be written as p1 power k1 into p2 power k2 into p3 power k3 and so on. What is quotient function? Quotient function is defined as number of numbers which are less than or equivalent to given number and are co-prime. Co-prime means first write down x. For every p1 numbers, one number will be divisible. Co-prime means it should not be divisible. So 1 minus 1 by p1. For every p2 numbers, one number it is divisible. How many it are not divisible? 1 minus 1 by p2. For every p3 numbers, one number it is divisible. How many it is not divisible? 1 minus 1 by p3. This you don't need to mug it up. That is the reason I said why 1 minus came. 1 minus came because quotient function means we have to find out a number less than or equivalent to given number and are co-prime. Co-prime means number should not be divisible. For every p1 numbers, one number it will be divisible. How many are not divisible? 1 minus 1 by p1, 1 minus 1 by p2, 1 minus 1 by p3. Not divisible means negation. Total minus the numbers visible. This is the definition of a quotient function. I hope it is clear. You don't need to do it directly, you will get it. Why quotient function? Because by using negative reminders, not all the problems will get the answer fast. Now we will start from 29th problem. I hope quotient function it is resolved. Uday Shankar, everything I will discuss other than academics at the end. 29th problem. Reminder 1. 5 power 37 is divided by 63. First thing, 63 is a composite number. So 63 is nothing but 9 into 7. So 5 of 63 is nothing but n into. Out of 3 numbers, one number it is divisible. How many it is not divisible? 1 minus 1 by 3. Out of 7 numbers, one number it is divisible. How many it is not divisible? 1 minus 1 by 7. 63 into 2 by 3 into 6 by 7. 21 3s are 63. So answer is 36. Quotient function of 63 is 36. Number of natural numbers less than or equivalent to given number and co-prime is nothing but a quotient function. So this is nothing but 5 power 36 into 5 power 1 by 63. 5 power 36 by 63 is 1 according to Euler's theorem. So answer is 5. Answer is 5. I hope 29th problem it is clear. Euler's theorem is used when the denominator is a composite number. In case if any student is using mobile and watching the class, kindly use headphones for good sound quality and not to get distracted by the outside sounds or the environments. 63, 3 square into 7 power 1. 5 of 63 is 63 into 2 by 3 into 6 by 7. Answer is 5. First one, I hope it is clear. More and more questions we will solve, more and more clarity we will get it. 30th question. 30th one. Reminder 1. 2 power 100 is divided by 153. 153. 153 is a composite number. So it is nothing but 9 into 17. 9 into 17. So quotient function of 153 is nothing but number into. Out of 3 numbers, one number it is divisible. So remaining numbers are not divisible. 1 minus 1 by 3. Out of 17, one number it is divisible. Remaining are 1 minus 1 by 7. So it is nothing but 153 into 2 by 3 into 16 by 17. 51 threes are. So it is 96. It is 96. So according to quotient function, according to Euler's theorem says 2 power 96 by 153 is directly 1. But I want 2 power 100. So 2 power 4 into 2 power 96 by 153. It is 1. So answer is 16. Answer is 16. What we are using in 29th and 30th? Euler's quotient function. Morning class we did a negative remainder. Now we are using Euler's quotient function. Euler's quotient function. Euler's quotient function. By using Euler's quotient function, you can solve the remainder problems quickly when the denominator is a composite number. When the denominator is a composite number, you can use this very fast. You can solve it very fast. Now 29-30, we'll solve some more problems so that it will be clear. 31. Reminder when 3 power 80 divided by 25. 3 power 80 divided by 25. 25 is nothing but 5 square. So this is nothing but quotient function of 25 is n into. For every 5 numbers, one number it is divisible. How many are not divisible? 1 minus 1 by 5. 25 into 4 by 5. 5 5s are 25. Answer is 20. So this is nothing but remainder of 3 power 20 power 4 divided by 25. This is 1. 1 power any number is 1. I hope it is clear. 25 is 5 square. Quotient function of 25 is 25 into 1 minus 1 by 5. 25 into 4 by 5, 20. So 3 power 20 power 4 by 25. 3 power 20 by 25 is 1. 1 power anything is 1. 31st, I hope it is clear. 32nd. Find the last 3 digits for 57 power 102. Remember, last digit of number n, it is nothing but remainder when number is divided by 10. Last two digits of number n, last two digits of number n, it is nothing but remainder when you divide by 100. Similarly, last 3 digits, you can take an example. Last 3 digits of a number n is nothing but a remainder when you divide a number by 1000. First make a note. 249. If I divide it by 100, 100 2s are 200, 49. 49 is nothing but the last two digits. If I want the last digit, divide the number by 10, get the remainder. If I want the last two digits, divide the number by 100 and get the remainder. If I want the last 3 digits, divide the number by 1000 and get the remainder. Naveen, it is 1 because of Euler's theorem. I am sure that you missed it at the beginning of the class. You came after the class started. I discussed what is Euler's theorem. Based upon Euler's theorem, a power phi of x by x will become 1. Last two digit, if I want to divide a number by 10, get the remainder. Last two digits, divide the number by 100, get the remainder. Last 3 digits, divide the number by 1000 and get the remainder. Right? If you want the last 3 digits divided by 1000, this is the concept. So divided by 1000, you will get the answer. Last 3 digits is remainder 1, 57 power 802 divided by 1000. 1000 is a composite number. Composite number, you can use Euler's quotient function, which is nothing but 8 into 125. 8 into 125. So 5 of 1000 is nothing but 1000 into 1 minus 1 by 2, 1 minus 1 by 5. 10. 100 into 4, 400. Quotient function value is 400. So these is nothing but 57 power 400 power 2 divided by 1000 into 57 square. This is nothing but 1 according to Euler's quotient function. 57 square is nothing but 57 square is 3249 divided by 1000 is 1000 threes are 3000. Answer is 249. I hope the idea is clear. Last two digits of a number is divide the number by 100. Last three digits is divide the number by 1000. 57 power 802 divided by 1000. 1000 is 2 cube into 5 cube. So 5 of 1000 is 1000 into 1 by 2 into 4 by 5. So 10 400. 400 2s are 800. Remaining is 57 square. 57 square. Morning class we discussed how to find out the squares from 35 to 75. 50 plus x whole square is nothing but 25 plus x slash x square. 3249 divided by 1000. 1000 threes are 3000. Remaining is 249. Similarly, I think this also we solved it. We got the answer 1. 3 power 20 power 4 divided by 25, it is 1. I hope the idea is clear. 31. Right? Answer is 1. Next 33. 6 power 84 divided by 49. So these are nothing but 49 is nothing but 7 square. 49 is a composite number. So you can use Euler theorem. The quotient of 49 is 49 into out of 7 numbers, 1 number it is divisible. So it is 1 minus 1 by 7. 49 into 6 by 7. 7 ones are 7. 6 sevens are 42. 6 sevens are 42. So these are nothing but 6 power 42 power 2 divided by 49. This is nothing but 1. 1 square is 1. I hope the idea is clear. All the problems we are discussing this concept. What is the concept? Reminder. A power 5 of x by x. A power 5 of x by x is 1. When x and a are co-prime and x is a composite number. X is a composite number. I hope the idea is clear. These all are based on Euler's theorem, right? Next, 34th. Idea is clear, right? Next one. 34th. Basic application of Euler's theorem, advanced level question. 5 power 7 power 9 power 5. 5 power 7 power 9 power 5. Naveen, avoid writing too many messages. You are expected to come to the class at the beginning of the class. This will be my last time I am telling when I am discussing a concept. Right? Don't expect everybody to do a free service to you. Right? You are learning. You need me more than I need you. 4 power 5 power 7 power 9 power 5 divided by 18. This is the question. Please put a star mark on the question. 5 power 7 power 9 power 5 divided by 18. 18 is a composite number. So it is 3 square into 2 power 1. First find out the quotient function. 5 of 18 is 18 into out of 3 numbers 1 number it is divisible. 1 minus 1 by 3. Out of two numbers, one number it is divisible. So 18 into 2 by 3 into 1 by 2. 6. So according to Euler's theorem, according to Euler's quotient function, 5 power 6 divided by 18 is 1. 5 power 6 divided by 18 is 1. Divide this number with this number. Morning in the first session we discussed close to 25 plus problems. We discussed the same model. Divide this with this. 7 power 9 power 5 divided by 6. 6 ones are 6. Remainder 1. So 7 power 9 power 5. When I am dividing by 6, quotient is k. Remainder is 1. Dividend is nothing but divisor into quotient plus remainder. So 7 power 9 power 5 when divided by 6, remainder is 1. So this question will move out to remainder 1. 5 power 6k plus 1 divided by 18. So now the answer is clear. This one 5 by 18 is 5. So some of the very advanced level questions in reminders can be solved very less in less number of steps and time by using Euler's theorem. Euler's theorem is used when the denominator is a composite number. In our morning session from 9:30 to 11:30, all the problems we solved all are from negative reminders. Then we have seen that not in all the values we will get the plus 1 or minus 1 so fast by using negative remainder. So that is the reason we introduced a concept known as Euler's theorem. Then we will see the drawback of Euler theorem. Then we will go to Chinese remainder theorem. I hope it is clear. Next answer is 5. Idea clear, right? 35th question. Students are expected to come on time and listen from the basics of class. If you come at any time and ask me a doubt, I am sorry, my answer will be no. Next one, reminder 1, 7 power 21 power 9 power 5 divided by 25. This is the question. Denominator is a composite number. So 25 is 5 square. 25 is 5 square. So 5 of 25 will be 25. Out of every 5 numbers, one number it will be divisible. So how many are not divisible? 1 minus 1 by 5. 25 into 4 by 5, which is 20. So according to the concept, remainder 1, 7 power 20 divided by 25 will be 1 according to Euler's quotient function. Now this is the value which I require. This divide with this. So if I divide 21 power 9 power 5 divided by 20, 21s are 20, remainder 1. So 21 power 9 power 5 when divided by 20, I get a remainder 1. So it is 20k plus 1. So this will become remainder of 7 power 20k plus 1 when divided by 25. 7 divided by 25 is 7. I hope the idea is clear. I want students to reply it in the live chat. I hope you are understanding how to use Euler's theorem for a single powers and also to use higher powers. I hope it is clear. Kindly reply it in the live chat if the concept is clear to you, so that we will go on to the next model in Euler's theorem. I want everybody to reply it in the live chat if it is clear to you. Is it clear to you? I hope it is clear. Riya says clear. Ravi, again I am explaining for you, Ravi. 25 is nothing but composite number. If the denominator is a composite number, then use Euler's theorem. 25 is 5 square. 5 of 25 is 25 into 1 minus 1 by 5. 25 into 4 by 5. So quotient function of 25 is 20. So 7 power 20 divided by 25 is 1. So divide this 21 power 9 power 5 by 20. 21s are 20, answer is 1. So 21 power 9 power 5 is dividend is the divisor into quotient plus a remainder. So 7 power 20k plus 1. 7 divided by 25 is 7. Next, another model, same thing. Now 21, 21, 21 and so on up to 25. 25 is 5 square. So 5 of 25 is nothing but 25 into 1 minus 1 by 5, 4 by 5, which is 20. By using Euler's theorem, we know that 21 power 20 when divided by 25 is 1. So divide this power. Power is nothing but 21 power 21 power 21 and so on. Divided by 20. 21s are 20, it is 1. So total power can be written as 21, 21, 21 can be written as divisor into quotient plus remainder. So this will become remainder of 21 power 20k plus 1 divided by 20, which is nothing but 21. I hope it is clear why it is 21. This is nothing but 1. 21 by 25 is 21. 25. I hope the idea is clear. Wherever the denominator is a composite number, right, you are unable to determine on which power of numerator when I divide by denominator, I will get plus 1 or minus 1. Please go ahead and use Euler's theorem. Please go ahead and use Euler's theorem. Euler's theorem helps us in determining which power of numerator when divided by denominator will give you plus 1 or minus 1. 36th problem. 37th exam model. Directly you can write the answer if you know the logic. 25. Already we discussed. 25 is 5 square. So quotient of 25 will be 25 into 1 minus 1 by 5, 4 by 5, which is 20. So this will become 4 power 20 power 5 into 4 power 1 plus 6 power 20 power 5 into 6 power 1 divided by 25. So this will become 1, this will become 1. 4 plus 6 is 10. Answer for this question is 10. I hope the idea is clear. Directly quotient of 25 is 20. So 25s are 100, remaining is 1 power of 4. 25s are 100, remaining 1 power is of 6 is 6. 4 plus 6 is 10. 10 divided by 25 is 10. 37th. Idea clear? 38th. I hope 37th question idea is clear. 38th. Good question, sir, it is. 38th. 38 and this question is based on backtracking. What is this backtracking? I will explain step by step. 6 power 83 by 49. 49 is 7 square. So 5 of 49 is 49 into 1 minus 1 by 7. 6 by 7. 42. So this is nothing but 6 power 42 by 49 is 1. This is according to the Euler quotient function. What is the multiple of 42 till close to 83? 84. So if 6 power 42 is there, 6 power 84 by 49 is also 1. Are you all with me? But I want 6 power 83. So this is nothing but 6 into 6 power 83 divided by 49 is 1. 6 divided by 49 is 6. 6 power 83 by 49 remainder we require, call it as x. When I further divide, if the numerator is less than the denominator, remainder does not change. 6x when divided by 49. I don't know the quotient k, but I know the remainder as 1. Dividend equivalent to divisor into quotient plus a remainder. So 6x is nothing but 48k plus k plus 1 divisible by 6 divisible by 6. K plus 1 should be divisible by 6. So k value is 5. So 6x is 49 5s are 245 plus 1 246. X is nothing but 41. X is nothing but 41. From whatever the known value, how will we find out the unknown value? Please go through this question once again. 49 is 7 square. Quotient of 49 is 49 into 6 by 7 is 42. 6 power 42 by 49 is 1. I want 84. So I want 83 from 84. So it is nothing but 6 into 6 power 83 by 49 is 1. 6 power 83 by 49 is x. When I further divide, remainder does not change. 6x when divided by 49, quotient is k, remainder is 1. 6x is 49k plus 1. 49k is 48k plus k plus 1. 6x is divisible by 6. 48 is divisible by 6. K plus 1 should be divisible by 6. So k value is 5. So 6x will become 49 into 5 plus 1. 49 into 5 is 245. 245 plus 1 is 246. 6x is 246, x is 41. I will do one more problem based on the same model so that this will be very, very clear to you. 38th problem. 39th. 8 power 83 divided by 49. 8 power 83 divided by 49. Same thing. What is 5 of 49? We got it as 49 is nothing but 7 square. 49 into 1 minus 1 by 7. 6 by 7. So it is 42. 42 means it can be written as 8 power 84 divided by 49 is 1. But I want 83. So this is nothing but 8 into 8 power 83 divided by 49 is 1. 8 divided by 49 is 8. 8 power 83 divided by 49, remainder we don't know, x. When I further divide, remainder does not change. So 8x is nothing but 49k plus 1. So these are nothing but 8x is 48k plus k plus 1. Divisible by 8, divisible by 8. K plus 1 should be divisible by 8. K is 7. So 8x will become 49 7s are 343 plus 1, 344. X is nothing but 43. Backtracking method to example. Riyaz, I hope it is clear to you. You can also use binomial expansion to solve the problem, but if you understand Euler, it will be very much easy. Directly you will get the answer. Anyway, in the third class, I will tell you how you can eliminate incorrect answer options. How you can eliminate incorrect answer options. Incorrect answer options, we will do it. First we are finding out the answers, then I will tell you how you can eliminate the incorrect answers. Smarter approaches, elimination methods I will discuss at the end, last class. 39, 40th question. Now this already we did it. 8 power 6 power 83. 6 power 83. How much we got? 6 power 83 by 49. We got 41. 8 power 83. How much we got? 43. So this will be, this if I add it, it is nothing but 41 plus 43 divided by 49, which is 84 by 49. 49 ones are 49. Answer is 35. Answer is 35. Idea clear, right? 40th question. 41st question.
Press the bell icon on the YouTube app and never miss another update.
All entire 6 hours is on reminders. All the variety of questions I will solve it in a single day. Now, find the digital sum for the following. Before that one, suppose 123 is there. What is the digital sum of this number? Digital sum of this number is nothing but sum of the digits till you get a single digit number. 1 plus 2, 3. 3 plus 3, 6. Can I also say this is nothing but the remainder when you divide a number by 9? 123 divided by 9. 9 ones are 9, 33. 9 threes are 27. What is the remainder? 6. So, one important concept, digital sum of any number. Digital sum of any number n. It is nothing but the remainder when you divide a number by 9. Please write down this. Digital sum of any number. It is nothing but the remainder when you divide a number by 9. When you divide a number by 9, whatever the remainder that you get it, that is nothing but the digital sum of a number. That is nothing but the digital sum of a number. I hope it is clear. Digital sum of any number is nothing but the remainder when you divide a number by 9. This is the concept. So, we are asked to find out the digital sum. Now, 9, what is the quotient function? 9 is nothing but 3 square. 5 of 9 is nothing but 9 into 1 minus 1 by 3, which is nothing but 6. Quotient function of 9 is 6. So, this is nothing but remainder 4 power 37 divided by 9. Already we know 9 quotient function is 6. 4 power 6 into 4 power 1 by 9. This is 1. 1 4s are 4. I hope it is clear. Digital sum for 4 power 37. Answer is nothing but 4. How you got 4? 4 power 37 by 9. 9 quotient function is 6. So 37 goes 6 times. 6 6 are 36. Remaining 1 power of 4 is left. So 4 divided by 9 is 4. Directly you will get the answer. 5 power 61. 5 power 61 is 5 power 6 power 10 into 5 power 1 divided by 9. This is nothing but 1. 5 divided by 9 is 5. I hope the idea is clear. Answer is 9 for the second question. Third question you don't need to solve. 3 plus 5 plus 1 is 9. 9 power any natural number digital sum is 9. 9 power any natural number digital sum is 9. 9 power any natural number digital sum is 9. 4 power 37 divided by 9. 9 is nothing but 3 square. So 5 of 9 I got it as 6. So 4 power 6 into 4 power 1 by 9. 4 power 6 divided by 9 is 1. 1 4s are 4. 5 power 6 divided by 9 is 1. 6 10s are 60. Remaining is 1 power of 5. 3 plus 5 plus 1 is 9. 9 power any natural number digital sum will be 9. 9 power any natural number digital sum will be 9. I hope the idea is clear. Next one. Give me 1 minute, sir. Solve one more question. 122 factorial. 122 factorial. 122 factorial. Another beautiful question. What will be the answer? Kindly reply it in the live chat. (122 factorial) D. 122 factorial. 122 factorial. What will be the digital sum? 122 factorial is 122 into 121 and so on. 9 into 8 into 7 and so on up to 1. Any number multiplied by 9, digital sum will be 9. Any number multiplied by 9, digital sum will be 9. I hope it is clear. Any number multiplied by 9, digital sum will be 9. Now what all we discussed, I am repeating. In negative remainder, we have understood the drawback. What is the drawback in negative remainder? How to find out which power of numerator. When divided by denominator, I will get +1 or -1. What is the drawback? Then we went into Euler's theorem. In Euler's theorem, what is the concept? Remainder a power 5 of x divided by x is 1. X is a composite number. And a comma x are co-prime to each other. 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 Now, what will happen if the denominator is a prime number? Another very important concept, Fermat theorem application. Please write down Euler's theorem over, then Fermat theorem application. Fermat theorem application. A power p minus 1 by p equivalent to 1. Fermat's theorem is used when the denominator is a prime number. Fermat's theorem is used. What is this p minus 1? How you got it p minus 1? It is nothing but, suppose for example, how many natural numbers less than or equivalent to 7 are co-prime to 7? If I ask you the same question, instead of composite number, if I write the prime, how many natural numbers less than or equivalent to 7 are co-prime to 7? Now easily you will understand why it is p minus 1. What are all the natural numbers? Natural numbers are 1, 2, 3, 4, 5, 6, 7. 1 is co-prime to 7. 2 is co-prime to 7. 3 is co-prime to 7. 4 is co-prime to 7. 5 is co-prime to 7. 6 is co-prime to 7. Totally how many numbers we got? 6 numbers. For 7 I got 6 numbers. For 13 I will get 12 numbers. For p I will get p minus 1. Remember, totient function of a prime number will always be prime number minus 1. Totient function of a prime number will always be prime number minus 1. Totient function of a prime number will always be prime number minus 1. Except 2. Remaining all the prime numbers are odd numbers. What is odd minus 1? Even. Right? Please write down this point. Totient function of a prime number other than 2 is always an even number. Totient function always gives an even number. Why? Because quotient of a prime number is always prime number minus 1. See, any number less than or equivalent to a prime number are actually co-prime to that given number. 7 is not co-prime to 7. 1 is co-prime to 7. 2 is co-prime to 7. 3 is co-prime to 7. 4 is co-prime to 7. 5 is co-prime to 7. 6 is co-prime to 7. So, quotient of any prime number other than 2, remaining all are odd numbers. Odd minus 1 is even. Remember Fermat's theorem and Euler theorem, the concept remains the same. In quotient function, denominator is a composite number. In Fermat's theorem, denominator is a prime number. In Fermat's theorem, denominator is a prime number. That is only the difference. I hope it is clear. This is Fermat's theorem. Now application. First one. Find the remainder when 9 power 1111 divided by 11. 11 is a prime number. If it is a prime number, you can use Fermat's theorem.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free AMC.